Hi, OMFG, or the Oblique Multipurpose Function Generator from Tenderfoot Electronics, is our 16 HP quad envelope generator and slew limiter module for eurorack. It's capable of more than just generating envelopes, and we'll look into all of the features in this video. To the side of the main OMFG module, you can see the 4 HP CV expander, which is included with the main module at purchase and allows you a bit more adjustability when trying to fit the module into systems of varying sizes. Looking at the panel, you can see how the 4 channels are arranged from top to bottom, with the functions of each channel laid out from left to right. Ignoring the expander for now, on the left we have the 2 inputs for each channel, with the input labeled EG being the trigger or gate input for when using the module as an envelope generator, and the input labeled in for any other signal you wish to run through the channel when using it as a slew limiter. The switch below the EG input is used to select between the one-shot attack and release envelope mode, where the envelope will start to fall as soon as the rise position is finished, and the attack sustain release mode, where the envelope will be held at its maximum level for as long as a positive gate signal is present. EG. So we're currently just going to send a positive gate into the EG input, so the envelope generator, and it's on the single trigger mode right now, so that was very fast. Let's slow it down a bit. So we should see the oscilloscope go up and then back down again. Yep, and it just does it one time. And now if we put it in the ASR mode, so each time I'm holding the gate input high, actually. So now you can see it's up nice and high, and when we turn the gate off, it drops back down again. High and low. And go back to the one-shot mode, straight up and down. Just like that. There we go. So to the right of the input jacks, we have the response curve switch, which can be set to either linear, as we currently are, or logarithmic, which we're now in. And for audio envelopes and envelopes to control filters with, quite often a logarithmic curve will sound a lot more natural. You'll get much more natural decay out of those. So if you want a very snappy envelope, you can stick it to the log curve, have the attack at 0. So it's really, really quick attack, and then just have like a natural decay out from that. Now in the center of the panel, we have the rise and fall dials, which I've already been using. The rise dial has a range of 0.2 milliseconds at the fastest, all the way to around 48 seconds, which you won't be able to see on the scope at the moment, without external CV. And the fall dial ranges from 0.7 milliseconds, so a little bit slower than the attack, but you don't really need decay faster than that, really, especially not for envelopes. So 0.7 milliseconds all the way to 57 seconds without external CV, so pretty much a minute. This allows you to go from really snappy envelopes to really long modulating swells of CV. When in looping mode, as we currently are, so you can see on the oscilloscope, the envelope is being re-triggered every time it reaches that 0 point threshold. This gives us a frequency range of around 0.01 hertz at the lowest, up to 600 hertz without the external CV input of the expander. When using the CV expander, the highest frequency tops out at around 1000 hertz, with the longest cycle that we've measured at the lower end being around 50 minutes to go from 0 all the way up to the max output, which is 8 volts, back down to 0 again. So you can use it for really, really slow modulation sources. Now the switch in the middle of each channel is the mode switch. So the middle position of the mode switch, which we're currently in now, is for like the one-shot envelope mode. So the down position is the looping envelope mode, where the envelope is re-triggered when it falls below the threshold set by the threshold dial here, which we'll look at in a bit more detail in a moment. And in the upper position, we have the cascading quadriture style mode, where the current channel is triggered by the previous channel's end of cycle output. So currently, yeah, you can see if we stick all of them on, we've got kind of a looping envelope from the first envelope generator up here, the first channel, but it's got like a delay between each envelope. And so of course you can lengthen that delay by changing the envelope times of all of the other channels. And let's go back to looping. There we go. Now to the right of each channel, we've got the two outputs, which we've already been using the main output, which gives you the rise and fall output of the envelope generator, or if you're using the channel as a slew limiter, you'll get your main signal output from this jack. And this output's connected to an attenuverter. So when using it as an envelope generator, it generates 0 to 8 volts at the output for a regular envelope. If you turn it all the way to the left, you'll see the signal's getting lower until it's inverted to negative voltages. And we go back up. So yeah, so we've got between 0 and plus 8 volts, or 0 and minus 8 volts. Now the other output jack is the end of cycle output, which is labeled EOC for end of cycle. And this basically goes high with a plus 10 volt output signal whenever the envelope has gone up and then is back below the threshold, the retrigger threshold set by the threshold dial. The final control on the main module that I've touched on is the threshold dial right at the top here. This sets the voltage at which any looping channels are re-triggered at, and can be set between 0 volts and 5 volts. And this is also the threshold at which the end of cycle output will go high. So if we take a look at that, so we've currently got this channel 1 in looping mode, and I'm going to turn the audio up so you can hear we're using it as like an audio oscillator. And that's the roughly 600 hertz. Let's get it down to around 80 or whatever that is. And so currently you can see that on the scope, we're being re-triggered when we get to 0 volts. The envelope goes upwards again, basically, it starts to rise. If we adjust the threshold, so we can increase that away from 0 volts up towards 5 volts. And you can see we're going up in pitch, and the bass level is rising as well. Oh, we've actually gone above where our triggers are set on the oscilloscope. Like that. Now, before we look at what each of these different functions can do and play around with some patches, I'll quickly just go over the CV expander, which, like I said, is included when you purchase the OMFG main module. So each channel has controls over the rise and fall combined, and then separate rise and fall levels. So again, I'll just turn the audio on, and I've got a voltage source which is variable from -5 to +5 volts, which I'm just going to input into each of these channels so you can see what happens. So let's set it to 0. So when we're using either the rise or fall, like individual CV inputs, an increase in voltage at the jack will actually lengthen the length of the rise or the fall. So essentially, an increase in voltage will reduce your pitch or frequency. And let's come back down. Like that. And let's do that to the full input just so you can see it affects both sides. So there we're increasing the decay of the envelope and reducing it. Now, when it comes to the combined rise and fall input, the input's actually inverted. So rather than an increase in CV going to that, reducing your looping frequency of the OMFG channel, you're actually going to go up in frequency. So you can use it almost like it doesn't track 1 volt per octave, but you can use that essentially as a pitch input if you're using one of these channels as a VCO. So let's turn the sound back up. So here I'm going to plug us in and I'm going to increase the voltage from my CV source. And decrease it. So, as you can imagine, you could input a sequenced CV from a sequencer. In fact, let's do that now. I've not pre-programmed this to any particular notes, and it's not quantized. So we'll see what comes out. So of course you could use this for all sorts of things, whether you wanted to use the OMFG channel that you're currently working with as a VCO or like an audio source, bearing in mind that it will be a unipolar output from 0 to up to +8 volts. Or you could use it to modulate the envelopes that you're using, or if you've got it as like an LFO, you can CV control that. In addition to that, because it's affecting the rise and fall of the slopes, if you're using the channel as a slew limiter, you can effectively use it as like a VCA/VCF in some ways. In fact, let's do that now. To do that, we're just going to turn it off from looping mode. And let's just put a basic square wave in. So this time we're not using the EG channel, we're using the input channel. And this works a bit better with linear slopes. You can use the logarithmic slopes as well, but the results are a bit more predictable with linear slopes. Okay, there we go. So we've got what is actually a square wave coming in from our audio source. But because the OMFG is acting as a slew limiter, you can see that the fall from the square is slightly slewed already, and we can increase that if we increase the fall, and we can increase the rise slew time. And you'll hear what effect that has on the audio. It's kind of almost like a filter. And so what we can do, let's use another channel of the OMFG, in fact. We'll set channel 2 to looping. We'll set a slow-ish envelope on it. We'll take the output of that, and first off, let's put it into the rise. So you can see that channel 1 of the OMFG is effectively acting a little bit like a VCA slash VCF, very crudely, of course. So if we take that same envelope and we put it into the 4 slope, you can see now we're up against the upper rail of the input signal, and we're just being held there when the signal's fully turned off. And let's try it on the rise and fall. So when we're affecting both of them, it's much more balanced and centered. And it's effectively a low-pass filter at this point. Now quickly going back into looping mode with the first channel, let's turn the volume back up again. There we go. So briefly going back into looping mode with that first channel, we've got a triangle wave, and just to show you the CV control of the threshold as well. Now the threshold is universal across all 4 channels, so there's only one threshold input, and that's right at the top on the expander. Let's set this channel into looping mode. So you can use that for all sorts of things. Again, whether you're using these channels as audio sources or CV sources or anything really. Now to have a closer look at the Quadriure mode, I'm just going to patch the outputs of each channel to the CV controls of the VCA just up here. So I'm using 4 VCA channels, and let's get 4 oscillators or other audio sources. So what we're going to do, we're going to put each of these channels into the Quadriure mode. So they're going to receive a trigger when the channel directly above them has reached its end of cycle. For channel 1, it's triggered by channel 4. So it goes in a loop. So you'll hear that they're kind of, they're cycling around with the end of one trigger triggering the next. And if we change the threshold, each channel will trigger sooner, and effectively the whole sequence will speed up. So you can hear with the switch to logarithmic mode as well, the first two channels have a much more natural sounding decay, which I think is really pleasing. The logarithmic mode will also slow down the whole cycle, I guess, of all four channels in cascading mode, because it just takes a longer time to sync back down to the threshold that you've set, especially if you've got the threshold all the way down at 0. You'll hear that, yeah, it takes a lot longer. So currently we've got channel 1 in just the standard looping mode, so it's not being re-triggered by the final channel, it's just sorting itself out. But then all three of the other channels are being re-triggered by their previous one, so they're all in cascading mode with the switch up. So the whole length of the sequence, and I guess the tempo, is determined by the looping frequency of channel 1. And of course, if it's re-triggering the next channel faster than it gets to the end of cycle, then the last two channels are never going to be triggered. Now, one thing you can do with the module is make patches like a bouncing ball patch, for example, especially with the ability to use the CV input module. Let's have the first channel in looping mode. And as the CV source, we'll just use the fourth channel just because I've got the cable in my hand already. And we're going to send its positive slope output, so not inverted, but the actual, the positive output into the rise and fall. Yeah. So that's one way to make a bouncing ball patch with the OMFG. Now, one final thing we're going to look at with the module, and it's by no means the last thing that you can do with it. There's an awful lot of patch ideas that we're not going to be able to go into just in this video. But what we will do, we'll set up a little sequence, so a 1 volt per octave sequence from our quantizer, just in the other case over here. So we have CV from our quantizer coming into the OMFG. And you might be able to see the output LED just showing that it is changing. We'll take the output of that into the 1 volt per octave input of one of our VCOs. So in this patch, we are sending CV into the OMFG, channel 1, from our quantizer. The output of that channel is going into the 1 volt per octave input of our VCO, and we're hearing the output currently. Now we're going to use the OMFG channel to add slew to the CV, essentially adding glide, so we can increase the rise. So whenever we go from a lower voltage to a higher voltage, it's being slewed. So there's that like upward glide, and we can do the fall as well. And let's take away the slew from the rise. And if we speed up the sequence just a bit. And of course we can control this with CV as well. So if we only want downwards glide, and we can use any of the other channels as our modulation source. And you could always add a gated sequence into the CV controls, so it's happening exactly when you wanted it. So can we do that here? Yeah, we can probably do that. So let's sequence the sequencer with our trig sec. And use the CLK as our clock source. So we should be getting that. And turn the swing off. And in fact, what we could also do, we could use another channel of the OMFG as our envelope for the VCA. So let's go use channel 2, and we can trigger that with the quantizer. And now we're going to use a gated sequence to increase the, let's do the rise. So now we're only getting the glide on that one note that we wanted on. And we can speed it all up. So now we've switched the glide to the falling portion of the CV. So whenever the CV is going from a higher voltage to a lower voltage, essentially a higher pitch to a lower pitch. Well, I hope that was interesting, and of course, if you're creative with your patching, there's an awful lot more that you can do with the OMFG. So if you have any questions or are interested in when this is available, or if it's available where you are, then don't hesitate to get in touch or leave a comment below, and we'll get back to you as soon as possible. But yeah, thanks for watching. Cheers.